This video is about the restoration and repair of this Pioneer SX-636 receiver from 1974. The work is complete and I'll attempt to outline some of the stages in the restoration in this video. First of all, I'll just switch it on so you can have a look at the front panel. It looks quite dull when the lighting's not on, but it comes to life when you power it up. And we're on an FM station there. You've got selector lights for AM, FM, phono and auxiliary. Nice touch, I think, is the dial pointer is illuminated, so that looks quite cool. You have a stereo pilot light, of course, and two tuning meters, signal strength on the left, and the tuning meter on the right should be dead central on that black line when you're precisely on your FM station. I'll take the lid off in a moment so we can have a look inside. First of all, just to say that all of the transistors have been replaced, all of the lighting has been upgraded to LED, and all of the electrolytic capacitors have been changed, as well as some ceramic capacitors like these ones which were across mains parts of the receiver. These have been replaced with modern XY safety rated capacitors. I've also installed three circuit boards in the receiver that I've designed. Two of them are for just ease of installation with modern components, modern capacitors, and also to change the lighting supply to DC. And this third one adds some extra functionality, gives me a preamp output, and I'll go into that in quite some detail a bit later on. So here we are with the lid off the receiver. I'll run through some of the circuit boards in a bit more detail later on, both on the top and underneath. And in case you were wondering, the FM station we were listening to was actually coming from one of these plug-in modulators connected to my computer. It's just a convenient way of getting audio into the FM receiver. The first thing I really wanted to talk about, though, was the dial lighting. It's quite an important feature of this receiver, and the original dial lighting consisted of 7 of these fuse-shaped bulbs, most of which had burnt out. One that hasn't burnt out is connected up to my bench supply at the moment, getting 8 volts DC. Now, these bulbs run at 8 volts 300 milliamps, that's 2.4 watts each, which gives you 16.8 watts across the whole dial. That's quite a lot of power just to light the dial face, and also quite a lot of heat going into the dial face. So I wanted to replace these with LEDs, and I found these rather nice replacements that have 3 LED chips in a similar shape of bulb. The other nice thing about these, they have a bridge rectifier in. I think there are 2 diodes under each of the end caps, and they can be run therefore from AC or DC. Now, although they can be run from AC, I didn't want to risk any peripheral vision flicker. So in my unit I've converted all the lighting to DC with this little circuit board here. So it takes in the 8 volts AC from the transformer, rectifies and smooths it. There's a 7 volt regulator. And one of the convenient things about this board, I've managed to sit it on top of the meter housing, so the lights in the meters themselves are getting power directly from the board through these stakes here, and that's also what's supporting the board, so I didn't need to add any additional screw fixings. I was just able to solder the board straight on top of the original terminals for the meter lights. And then the remaining 5 lights behind the dial itself come off this black and blue wire, ground and positive. The light in the tuning pointer here, that's coming from the board as well via an additional resistor just to drop the voltage to the correct voltage for one single light. And in fact I've got a surface mount LED in there. I needed the smallest possible one I could get to fit in the enclosure at the top of the pointer. A couple of other things to say about this board. There's a hole in the middle, as you can see. That was deliberate because there's a screw underneath to remove the cover from the meter enclosure. I didn't want to block that. And the reason I'm using 2 capacitors there rather than one large one, it's really for clearance. So if I can get the camera around the edge here, but I wanted to make sure that when the lid was on, it didn't foul that board. And as you can see, there is plenty of clearance there. I'm just going to say a little bit more about the lighting modifications to this receiver. Here's the circuit diagram of the original setup with 8 volts AC coming in, powering the 7 8 volt 300 milliamp bulbs, 5 of which are behind the main dial, 2 behind the meters. And as I mentioned before, that is quite a lot of power. That's 2.4 watts each, 16.8 watts in total. Plus the little light in the dial pointer, which was 8 volts, 50 milliamps. So the first thing I did, as you saw, was convert this to 7 volts DC, and I can show that on this slide. So here's the 7 volts DC coming in, dropped a little bit just to take half a volt off, just to get the intensity right on the backlighting for the meters and the dial, and also dropped with a larger resistor for the single LED in the dial pointer. Now that leaves the 4 lights that do the selector positions, AM, FM, phono and auxiliary. Now they get a common feed from this line here, so 6.5 volts in this case, and then to turn each one on they are grounded in turn through the selector switch back to ground here. So all I need to do, bearing in mind that only one's ever on at one time, is put a resistor in this ground return, and that's what I've done here. There's a 2.2k resistor inserted here, and you'll see this mysterious pin 6 has appeared. Well, we got lucky here, because if I go to the next slide, which has a photograph of this lamp board, pin 6, I was able just to swing the wire here to this unused pin and then put the resistor between that pin and the original ground point. And there's an unused pin here because this receiver is also made in a variant that has long wave on it, and so there's an unused light position here, a selector light for long wave. Not used in this model, but the pin still exists, so that worked well in this case. Now the one thing I haven't mentioned yet is the stereo indicator light. That's fed from a completely separate circuit. It's a 6 volt 30 milliamp bulb, and if I go to the next slide, which shows a little bit more detail, here's the light assembly, and the plus side of the 6 volt light comes from the power supply board. There's actually a 13.5 volt rail that powers the tuner section here, and then there's a dropper resistor 270 ohm here just for that light, and then the return path for the light actually goes through to the stereo decoder chip here and is switched to ground when it detects a stereo signal. So to make this into an LED, all I need to do was put a dropper resistor here, a bigger dropper resistor, fit the LED, and that does work, but there's a slight problem because when it's not detecting a stereo signal, there's some leakage through this chip and the stereo LED just glows very softly. So it's not a problem when there's a tungsten bulb in there, but with a much more sensitive LED, it never fully extinguishes. So to overcome that problem, it's just a matter of putting a 10k resistor across the LED, and then it goes out completely when it's not on a stereo station. And just to show the location of those resistors, so the 5.6k on the power supply board is here, and not a very good photo, but the 10k that I put across the stereo LED is at the other end of the lamp board here. So just a quick tour of some of the rest of the top side of this amplifier receiver, and then we'll have a look underneath. This is the power supply board. As with the other boards, I've changed all the electrolytic capacitors, most of the, well, in fact all of the semiconductors on this case, the transistors and the diodes. This is the main bridge rectifier here. These capacitors were very much depleted and did need changing. Fuses were all fine, all intact. The only thing I've done is this fuse was a 3 amp fuse for the dial lights. I've dropped that down to a 315 milliamp fuse, more in keeping with the current taken by the LEDs. The main filter capacitors have also been replaced, and we'll have a look underneath at a circuit board I designed to make connecting the wiring up to these a bit easier. This is the tuner board, FM and AM, has 3 original ICs on there which are all working fine. I have no equipment for lining up FM or AM, so I was very careful not to make any changes to that board that would throw the alignment off. I have changed electrolytic capacitors, and some of them have been changed for these film capacitors. The reason for that is a lot of them were these little blue Sanyo capacitors, pretty much all of which were open circuit. But fortunately none of that seems to have thrown off the alignment of the FM or AM receivers. It seems to be working just fine, so I'm happy with that. Onto the main power amplifier. I have changed the main output transistors. We've got MJ21194 and 21193 pairs. And it's getting more difficult to find through-hole components. I had to order, I think the NPN ones came from Farnell and the PNP ones from Mauser in America, or the other way around. And you find you play this game a lot now with transistors in particular, trying to find a supplier who's got the ones you want in stock. Otherwise, they have extremely long lead times. You might be months and months before they're expected back in. So you do have to look around all of the available suppliers and pretty much pounce when you can, when you see the ones that you want in stock. But anyway, I did manage to get everything I wanted for this board. Capacitors changed again, and also I changed these trimmers. These are the trimmers for the bias current. The original ones were these single turn ones. I put in multi-turn, 10-turn pots. These are working, but they're old, and I don't want any risk of the wiper lifting from the track and getting too much bias current flowing. And the other board, which you can just see behind here, we'll have a look at from the underside of the receiver, and you can see that one a little bit better. This is the tone control board. So here we are looking at the underneath of the receiver, just standing on its end, just the easiest way to get it stable. So first of all, I just want to show you the board here for the main filter capacitors. Basically, the original capacitors have these long terminals on which the wires were wrapped around, but unfortunately modern capacitors don't really have that. They just have these little snap-in lugs. So what I ended up doing was designing this very simple board which has allowed me to push the capacitors through a little bit more from the top and solder them on, and then I can terminate all of the wiring onto the board here. I also took the opportunity to add 2 bleeder resistors. When you turn the amplifier off, it immediately removes the load from these capacitors, and they hold their charge for days. I did accidentally short one out, and it went off with quite a bang, so although it wouldn't shock you necessarily in this case, they're only about 30 volts they charge up to, you still don't really want that happening, so those resistors bleed the charge down within several seconds after turning the thing off. The other thing with this board, you probably notice the tracks are quite thick, which I wanted obviously to keep the resistance as low as possible to these main smoothing capacitors. But also, as well as using thick tracks, I've actually double-sided them, so you've got the copper thickness on both sides of the board, just to get as much, just get as low a resistance as possible in those tracks. We discussed the mains power input area. First thing was to change the mains lead. It had a very short 2-core single insulated flex on it originally. It's now got a 3-core flex, and the unit is properly earthed. This is a multi-voltage model, so if I go around the back, you've got a voltage selector here, and also you have 2, not so clear, but they're 2 outlets, American style outlets, one of which is permanently energized and one of which comes on when you switch the amplifier on. So this is quite useful for connecting auxiliary bits of equipment in your hi-fi setup. However, this is now the rather strange situation where I've got 230 volts sitting on American style mains connectors. I did think about bypassing them, but actually in this multi-voltage unit they are used as sort of terminal tie points rather than having a separate terminal strip that I've seen in some of the single voltage ones. So I have left them there, and I'm using them to keep all the wiring as it was before. This capacitor has been changed for a modern XY safety rated capacitor that just sits between live and neutral. And then the wiring to the switch is bundled in rather oddly with all of that other signal wiring. Bear in mind this is still mains wiring here, and goes to the power switch, which I've just sleeved in a bit of heat shrink, and also under here it's a double pole switch. Also under here are 2 more class XY capacitors sitting across the switch contacts just to reduce the arcing a bit when you turn it off and on. Unlike other Pioneer receivers that I have restored, this is a much more robust switch, and when I measured it I was getting a very good 0 ohms on each pole, so I'm quite happy with the operation of that switch. So other changes underneath, no surprises really. As before, I've changed all electrolytic and tantalum capacitors. Many of them have been, the smaller value ones, I've actually replaced with film capacitors rather than electrolytic. Most of these are in the signal path. I think that's probably a better choice than electrolytics in the signal path. Transistors changed again. Switches cleaned with switch cleaner. Rotary controls cleaned with appropriate spray for rotary controls. And everything seems to be working fine. I've got no crackling or intermittency that I can detect. The top board here, that's the phono preamp board. That's just had new capacitors and transistors as well. The main function selector switch, which is what chooses between FM, AM, aux, phono, and also drives those selector lights. That's also been cleaned and seems to be working perfectly. This little terminal ground strip here and another one down here, both of those had quite a bit of corrosion around them. I think what had happened is from the factory they had soldered the strip to the chassis and obviously applied some fairly corrosive flux which had kind of eaten into the metal a bit, but that cleaned off okay, and I've just touched it up with a bit of silver paint so you don't really see where that corrosion was, and also just protect it from happening again. And those are fine. I think that they're giving a rock solid connection to the chassis, so I'm not too worried about that. And that is it really for the changes underneath, apart from one more change that I've yet to make, and I'll now attempt to explain a bit more about that. So one thing that this receiver is missing that I'd like to add is a preamp output. That's an output that's affected by the volume and tone controls but is taken off before the power amplifier. The reason I want to add this is so I can continue to drive my subwoofer, which I find does help with the acoustics in the room that I'm going to be using this in. Now, I think I can do this quite easily. These wires here, the green and yellow, are the left and right audio signals from the tone board going into the power amplifier board, so I could pick those off here. This red wire is 30 volts DC, going to power the tone board and also powers the phono board, so I've got a source of power here. This blue shielded wire is the left and right and ground out to tape loop 1. Now this machine's got 2 tape loops. I don't need 2, I'm probably not even going to use 1, but I think I could convert tape out 1 into preamp output. Now what I've done, I don't want to connect these directly because I want the preamp output to be buffered. If you fed anything back down here accidentally, it's going to get straight onto the power amp at full volume and cause all sorts of problems. So what I've done, I've designed a little circuit board here, which I've yet to populate. This will sit on top of these 3 wire wrap stakes and pick up the left, right and power inputs. I'll swing these the left and right tape outputs onto this board, and then when the board is populated it will act as a buffer amp and provide a buffered version of this preamp signal out to tape out 1. The little hole in the board here is just because there is a capacitor here that it won't clear otherwise, and the legs are too short to bend it over. So I'm going to go and populate this board, test it on the bench, and then fit it, and we'll see if it achieves what I was hoping to achieve. I just wanted to say a little bit about the circuit that I'm using for the preamp buffered output. This circuit is based on one I found on a website, and I'll put the link to that website in the video description. What I was looking for was a circuit that would be transistor based, using transistors that I already have in stock for refurbishing the receiver. I needed to have a high input impedance. Ideally I wanted the input to be in phase with the output, so no phase inversion through the amplifier, and I wanted the ability to add some gain into the amplifier. I also needed to be able to run it from the 30 volt single rail supply that I have conveniently available inside the receiver, and this circuit meets all of those requirements. So as shown, this is just one channel, so this is duplicated in the actual design for 2 channels, but as shown this circuit has unity gain, and by adding just one resistor and one capacitor I can add 6 dBs of gain using the components shown, and by varying these components I could add more gain. In my design I chose to put a jumper link in here just so that I could remove this extra gain if I didn't need it, but as it turns out it looks like I will. In terms of input impedance, well, that's determined by these two resistors in parallel, and that gives 857k, which is very high, and therefore I don't expect this circuit to interfere with the circuit that goes from the tone board into the main power amplifier. Bear in mind I'm sitting across that point in the circuit. Now, I'm not going to attempt to explain the full theory of operation of this circuit. I wouldn't do it justice. But if you are interested, I do recommend you read the web page that I'll link to in the video description. It explains this circuit based on slightly different resistor values and with 9-volt operation, but the theory is exactly the same. It also tells you what other components you can put in this feedback loop to get different amounts of gain. It is a really useful building block circuit to have on hand. Well, welcome back to a very messy workbench. The preamplifier buffer module has now been assembled and is currently under test on the bench. Seems to be working okay. I'm feeding in 30 volts DC from my bench power supply, which is the supply rail that it will be getting when it's in the amplifier itself. That is dropped through a 3.3k resistor, and that gives me 18.49 volts to run the preamp buffer module at 3.4 milliamps. I think that's absolutely fine. I don't think 3.4 milliamps extra on the main amplifier will be a problem, and the circuit was designed around values of 18 volts, so that's good as well. I'm also feeding in a 1 kHz tone. These are the left and right inputs here, and if we go up to the oscilloscope, try and go slowly so I don't make everybody ill. The top trace is currently looking at the input from my signal generator, and the bottom trace is the output of this one channel of this preamp buffer module. And you can see we've got 1 volt RMS going in, 1 volt coming out, so unity gain, and they're in phase with each other. Now, one thing I did want to incorporate into this module was the ability to add some gain. I did add a preamp module to another amplifier that I restored, a different one, but the output level wasn't quite high enough. I've had to turn the gain right up on the subwoofer that I'm trying to drive with it. So this time I wanted the ability to add some gain, and you'll notice that I've got two links here, one for the left, one for the right channel. And if I bridge those links, it should give me an additional 6 dBs of gain. So what I'm going to do, I'm going to go back up to the scope, and now the bottom trace is the output, and if I try and add this link on, hopefully you will see the level increase. Here we go, there we go, that's the link in place, and now we've got 2 volts RMS out for our 1 volt in, so we've got 6 dBs of gain. I think that'll be useful. Although the point at which I'm taking the preamp signal off in this amplifier I think is a bit higher level than the previous amplifier that I did, it's still useful I think to be able to bring the level up if needs be. And if that level isn't adequate, I can alter the value of components on this module to increase it further, but I think it's going to be adequate as it is. And just for completeness, I'm now running a frequency sweep on both channels with the 6 dB U-link in place. And I'm getting a nice flat signal from 20 to 20 kHz. So it's the next evening and the receiver is switched on and undergoing some tests, and the preamp board is installed. And I have to say it seems to be working just fine, which is quite a relief. So it's held in here not with any screws or anything, it's using the wire wrap terminals that were carrying the tape outputs. The left and right is disconnected and it's just using the ground, and then the other support comes from these three terminals here, which are the 30 volts in and the left and right audios, and we've got a little hole here with the capacitor peeking through. Now I have decided that I am going to keep these 6 dB links in place. The reason for that is I've made some measurements of the preamp output voltage, and it compares very well with the voltage that I had with an old Marantz receiver that I was using to drive my subwoofer. Basically, I made some measurements on that before I sold it, and when I had 1 volt RMS at the preamp output, I was getting 8.83 volts at the speaker terminals. So I've got a test set up here to see how close to replicating that I am with this unit. I've got 2 8 ohm dummy loads across the speaker outputs just so that I don't get deafened. I've got a 100 hertz tone going into the amplifier, and I've got my scope set up here with the lower trace looking at one channel of the preamp output and the upper trace looking at one of the speaker outputs, and they're set for different scales. The top trace is on 10 volts per division, and the bottom trace is on 1 volt per division. So if I now turn up the volume on the receiver, and we'll just see what happens, what sort of power, what sort of voltage level I'm getting at the speakers when I get 1 volt RMS at the preamp output. So here we go. I'm going to turn up now, and we're coming up to 0.8, 0.9 volts. Let's see how close I can get to a volt. Okay, 1.03, that's close enough. So 1.03 volts at the preamp output, and I'm getting 8.58 volts at the speaker terminals, which is incredibly close to what I was getting on the Marantz unit with its dedicated preamp output. I had 8.83 volts at the speakers, which I think equates to about just over 9 watts. So yeah, I'm happy with that. The relationship between the preamp output voltage and the power amp output voltage is good, and I'm going to keep those 6 dB links in place. And just in case you're interested in seeing the power output of this amplifier while I've got the dummy load set up, I've now got 1 kHz tone going into the amplifier. The top trace is one of the speaker outputs, and the bottom trace is still one of the preamp outputs, just so that you can see that the power amp breaks up long before the preamp does. So if I turn up now and watch the yellow trace to the point where it starts to clip, okay, it's just squaring off there, so I'll back it off until it's clean, which is just about there, and we've got 14.5 volts RMS at the speaker outputs, and you can see even when I run it into clipping, the preamp output's still clean. So we had 14.5 volts. If I just do a quick calculation based on 14.5 volts, so 14.5 squared divided by 8 gives you 26 watts into 8 ohms, which is about right. I think these amplifiers are sold as 22 or 23 watt amplifiers, or were sold in the mid-70s. I was just going to say a little bit about the manufacture of these PCBs. This is the bit I've had so much fun with. I've really enjoyed this. So I've been using a company in China called JLC PCB, and linked in with them is a piece of software called EasyEDA. It's free, and it's an electronics CAD package. It takes a little bit of time to learn how to use it, but there is loads of help on the web. So you start with your circuit design, and you can just drag on components and wires to link them up. And once you've got that looking as you want it, you then convert it to a PCB, and you can then position the components where you want them. Now I've already done that for this, so if I click on the PCB, there you go, the red tracks are on the top layer, blue ones are at the bottom layer, and the writing, the silk layer, is there in yellow. So when you first create the PCB, all of the components are just in a pile at the bottom, joined by thin elastic wires, and that allows you to position them, and then you can put in the tracks where you actually want them. So for example, if I delete this track, you'll see that it's now telling me that there needs to be a connection between these 2 points, and if I move the component about, that connection will move. If I cross over and a track that's already there, you'll see it crosses it out to warn me that that's an illegal position. And then to actually put the wire in, or the track in, you just choose the wire, choose the layer that you want. I'm going to have this one on the top, and just simply click where you want it. Job done, and that's now connected up. It really is great fun. And then once you've got this looking as you want it, and I'm just going to undo my changes there just so it's back as I had it originally, you can save the board, and then you can create a 3D model. So if I click on 3D, and you get a really nice 3D representation of the board. You can look around the back of it as well if you want to. And remember, this one I added a hole as well so that I could fit it over the top of a capacitor. You can choose the size of the pads here, the holes. I made these slightly larger and elongated because they were going to fit over the pins that were already on the amplifier board. And then once you've done this, you save it as a Gerber file. It may be pronounced Gerber, I'm not too sure. It's spelled Gerber, and that file is what gets sent to the manufacturing company, JLC PCB, and they turn this around into a blank board. They also offer services that do populated boards, but I just want the blank boards. And it comes through really fast. They make the things in about 2 days, and then depending on which delivery option you choose, you get them back within about 5 days. So I'm very impressed with the process of ordering PCBs online, and it really is so satisfying, such good fun. This was obviously more complicated. The other two that I made, the lamp DC board and the board for the capacitors, were much simpler. So this one's finally finished. I'm going to put it into service as my main hi-fi amplifier for a while. It's been a huge amount of fun doing this one. Really enjoyed it. It's lovely to work on. Nice big open chassis. I couldn't find a UK price for these, but in America they were sold in 1974 for $350, which if you put that into an inflation calculator works out at about $2,200 today, or about £1,700. So they're definitely worth hanging on to, and I was surprised how well this one had survived in very good condition since 1974. I'd like to play a bit more music for the video, but I'll hit a YouTube copyright strike, so I can only play a few more seconds, and I'll have to say that's this one finished. Thank you for watching the video. I hope it wasn't too tedious.